Start recording. Okay, good evening everyone. Welcome back to Database course. It's week 18, lesson 2. We will talk about today advanced time series and time series statistics coding dojo. So before moving ahead, let's do a 3-minute breakout room activity. In this, these are the 3 questions. You need to answer which method of pandas is used to convert the date and time input into object date and time. Okay, so you can use it further. Write the name of the method used to add or subtract the days from the date and time, because we can't subtract the days directly from the timestamp. Write down the steps required for time series dataset analysis. You don't need to dive very deeply. You need to write only the top level. 5 steps which is required for dataset time series analysis. Okay. So I will share the link in the chat as well. And I will open a breakout room. Okay.
Minutes will go really fast, Nerja.
Yeah, thinking about the answer. We can pause the recording.
Yeah. Out of time.
Okay, welcome back. Okay, let's go over the answer. So, which method of pandas is used to convert the date and time input into object date time type? This is correct answer from both rooms. Good. And write the name of the method used to add, subtract the days from date and time. The correct answer is pd.to underscore delta time. Okay. Or time delta. This is a method we use to subtract and addition of the days. And we use a string format type to format your date and time. Okay. So this is we use for that thing. And then write down the steps. Convert to datetime objects at datetime to index. This is good, much appreciated and great. Okay. If anybody have any confusion, they can discuss with me after a class. Thanks a lot. So let's start. So recap. So in the previous lesson, we have discussed about the what is time series, different type of time series we have discussed, that is regular and versus is events. What is a resampling in time series? Why we need it? How to impute the missing value in time series data set. We have discussed the 4 methods of imputation. Announcements. Next week is again, it's an interesting week. You are going to learn about the Tableau. Okay. So it is highly recommended to everyone. Please install this your public desktop version, which is a free one for the Tableau on your system. Here is a link. If you want to go over the installation steps, this is given here. Okay. So you need to go through these steps. Okay. If you find any issue, you can contact me. Okay. Assignments. So your required core assignments is resampling date time data, which we have covered last time. Preparing time series from wide form data. This is we will continue today. And core project for part 1 covered today. Okay. This assignment will take your time because it's a big assignment, and it is going to be your portfolio project as well. So try to make it more professional and use proper functions, well-organized code. That would be very helpful for you. Okay. And for the before like jumping onto the next lesson, this is highly recommended. If you can, all of you can read these before the next lesson. That is about the sets, groups and hierarchies and filters from the before the first lesson of your Tableau. That would be good for all of you. And these one. Okay, this is the suggested one. Before starting today's lesson topics, this is a just heads up. Maybe from any one of you are facing the issue to plotting this graph. Okay, it is not showing the proper months at the x-axis. This is not a problem at your end. There are some like the updates. Matplot lipstick artist. Okay, right now you are maybe using the data frame name dot plot, and then you are setting the major locator tick and the minor or the other ticks. How you can fix this? You need to use these 2 lines of the code. You need to create a figure and then the subplot inside the figure, and then you can plot your graph. Then it will give you the good results. So this means you need to replace this line with these 2 pieces of the code. Okay. So this is update if anyone is facing the issue in plotting this graph. Okay. Today's learning objective. Today we are going to calculate the time series statistics. Under this, we will discuss calculations comparing and normalizing the values in the time series, rolling statistics, feature engineering, calculate seasonality of the time series, how to answer the stakeholder questions. Okay. Very interesting topic which we are going to discuss today about the time series. Now look at this picture. This is from our previous lesson when we discussed about the definition. So I would like you to go over the few more terms, that is stationary and non-stationary, seasonal, cyclic, trend, and what other types in the time series when you heard about these terms. So if you look at this first graph, here we can see this is on the, you have a year, and there is the data in the millions. This is the sales of the houses, right? In each year. If you look at this graph, you can see it is showing some your trend, because it is here is a up, down, and going over the year. And if you look between these 5 years, 1975, 1980, then 1980 to 1985, it is following some trend up and down, right? In maybe in some years of the month is a high sale, in some years this is down, and so on. So these kind of your data set in time series is known as non-stationary. Why we call it non-stationary? Because here it is like tough to predict the trends, right? Seasons and your data points over the time, because it is changing over the time with the mean and with the standard deviation. Your mean is changing over the time. Your like standard deviation or variance of the data is changing over the time. We also name it seasonal and cyclic behavior as well, because it is showing you the up and down between the 5 years at a different levels, right? Up and down. Now, if we go to the right side picture, this is also seems to be non-stationary. This is showing the number of days on the x-axis and showing the number of the bill contracts US Treasury based on the number of days, right? Again, we can see this is a downward trend, right? As the number of the days are increasing, these bill contractors are decreasing. So this is also non-stationary, because on each day, the level is different. Mean of the data set is different. It is varying or going down over the time. And if you look at this picture, this seems to be also non-stationary, because it is showing you the trend over the years, right? And it is showing how much electricity was produced over the year. And this also seems to be trend, and you can call it trending. The data set trends, it's showing you the trends over the year, when it was a low in the trend, when it was a high in the trend, right, in the data set. But if you look at this graph, this is showing on the daily basis, and you can see there is a no trend. This is a straight hairline, but it is showing you the very like noisy data. It is not clear at all. There is a no season, no trend. It is not going up and down. It is also starting from here 0. So this means here the mean is 0. This is stationary data. Variance is, the standard deviation is not changing over the time. So these are the important terms in the time series about this stationary, non-stationary, how the data look shows you the trends. You can see these things by plotting the graphs, right? What questions do you have about these terms? Very important. If any confusion to understand or interpret these things, please feel free to ask. All right. Okay. So today we will focus on the calculation and statistics of the time series. Okay. In this, we will talk about the two things, comparison and change in value, under which we will talk about the difference method, your percentage change method, sum method, and how you can manually normalize a specific date, or you may want to do the calculation on a specific day over the time. And the other is rolling statistics. This is the rolling method, very popular, and how you are going to use it by following the methods mean and standard deviation. We will discuss it in detail one by one, these methods. So here we go. So now this is the like picture from our previous lesson. We have used this graph in the previous lesson as well. Here, if you remember, we plotted the like stock market price over the quarterly 3 months, right? With the major and minor ticks. So if you look at these, how did it look like? Can we see it? It's a trend. It's showing the trends over the year, over the month. Is this non-stationary or stationary?
No.
Yes. No, it's a yes. Sorry. Yes, non-stationary. Because here your mean is not stable. It is varying over the time, and your like standard deviation is also varying over the time. It's tough to predict, right? So now what we will do? Very important thing. Whenever you have a time series data set in the non-stationary form, you need to make it in stationary form before you use it for forecasting model. Why? The reason is because in your non-stationary time series data set, your model will not be able to predict or learn anything in a very good way, because your mean and standard deviation is not stable. It is changing over the time, right? So this is very important. Whenever you are using the model for the forecasting or modeling the time series data, you need to like do the analysis, make it stationary, and then you can go ahead. So for those, one of the method which we use to remove the trend and seasonality up to or reduce it, so we can use the data set further for modeling. The first method is difference method. This is a very common and popular method we use in time series. So in this, how you can use this? This is, you can run over the data frame. You will use the data frame dot diff method. Okay, and it will change your non-stationary data into stationary. Now see the difference here. How it look like? This is changing over the time. No stability. There is a, it's a like changing from the mean every time. But when I applied the difference method here, it is showing your data over the time through the mean. It's a stable now, right? How it works? It just returns the difference between the values for each row by default from the previous row. Okay, this means it will subtract the value of the current row from the previous row. Okay, so this is the way how it is calculate the difference between your, like the given in the time series data set. So applying this, your data set will become in the form of stationary, regular, like in this form, where you can see the mean is stable, your standard deviation is stable. Okay, what questions do you have about this method? All right, we will move ahead. The next method is cumulative sum. This is another very popular method. Okay, you use oftenly these methods in real time whenever you want to look for the total happenings or total, like the say, if we take an example here, COVID. If you want to see the total cases of the COVID over the year, right, from the start, like 2019 to 2020, 22, you want to see the total COVID cases based on each country, then this method is very useful. What it will do, it will start doing the addition of all your predictions, or sorry, all your values of the data points from the historical data, and it keep on adding. Like how you can use it, you can apply it on the data frame dot consum method. And now what it will do, it will start doing the addition from the previous to the next one, then this plus this one, and so on. When you apply this, okay, this will give you the view of total contribution so far for given measure against a time. Like if the total cases in, let's suppose in the COVID in one country, let's say in the USA was a 2000 in 1 year, and in 2019, and if it's in 2020 it's a 2000 more cases, then it will show you in 2020 the total cases 4000, right, doing the addition of the your previous one. So these are very helpful when you want to look for the total contribution of the data points over the time. Okay, at that time you can use it, very useful. Okay, so now the third method is percentage change. Okay, this is very useful when you want to like see your, like the output in the form of percentage. For example, if you are interested to look for the Google, Facebook, or other, like the big companies want to see their revenue in the form of percentage over the time, right, then they can apply these methods. How you can apply the method? This again, the data set, this is percentage change multiply by 100. So it will give you on the y-axis the output in the form of percentage. Now it is showing the stock market data over the, like the time, in the form of percentage of the price, right? So this is the use of percentage change. It is like just calculating in the form of percentage over the time. Okay. Now, what questions do you have till so far? All right. If something come up in your mind, please feel free to ask. Okay. And here we will talk about if you want to normalize to a specific date and value. Okay. So now maybe I'm interested to like normalize my this date of the data point, right? It's your 2018 for 2nd of January, right? So what I will do, how I will do that, we will take the data frame dot location, we will set the date, right? And then we will find out first value. Okay. When you find out the normalized value, you will subtract it from whole data set. Okay. This is from the whole data set. So this is just like you are normalizing the things. Like if you remember a few seconds ago, we have discussed about the difference method, right? That was also doing the difference from the current one from the previous one, right? Now in this case, what is happening? We are doing it manually, right? In this case. So in this case, you will pick up the like the time data point over the time which you want to normalize, right? And then you will subtract it from the whole data set. So it will normalize the data from this date, 2018, year 2nd of January, and then going on from this date. Okay. Here you can notice here is the mean is 0, right? But the big difference is this. If we go back now over here, okay, when you applied the difference method here, right, it was subtracting your current value from the previous one. The first one is converted into NaN because it will subtract it from itself. Then it will go further. Okay. But here you can see it remove your all trend and seasonality when you are using the difference method, right? It is stabilizing your data. But when you are using it manually, it is stabilizing it, it is normalizing your data, right? But it is not losing its trends over the time. It is showing you still, right? This means its mean is somehow at some point is stable, but not fully, right? It is still going up and down. This, okay? So this is the difference. You need to take care of these things when you want to use this method or when you want to use the other methods to normalize it, right? Your time series data over the time. So in this, now I'm okay. So now if you want, here we are doing this. If you want to show this specific, like the specific date manually in the form of percentage, you can do one thing. This is your normal value. We got the data now since from your 2nd of January 2018 and going on up to the end. Now, if you want to show in the percentage form, what you will do? You will take this date divided by value for normalization multiply by 100. So we are applying it, the manual method to change it into the percentage form. Okay. Earlier we have this method as well, PCT underscore change. Okay. So, but the big difference is that it is removing all trend and seasonality. But when we are maintaining the trends and the seasonality over the time with the mean 0, right? Trying to that, it is your manual method. Okay. So this is a difference when you will apply this. So you can see these things when you will plot the graphs in this. Now, what questions do you have about these all methods? Any question? All right. So we will move ahead. This is another very important topic. Very, very often used method in time series, right? Especially it is helping you when you want to forecast, you use your data set for forecasting in time series. When you have a very big data, it's tough to like forecast the things to take the values, right? So this method is useful at that time. Okay. In this, what is the advantage? Why we use this? We call it moving average or rolling average as well. You can make it weekly, monthly, and based on the years as well. Okay. So in this is moving average is extremely useful for forecasting long-term trends. Okay. And in this, we use this method. This is called like this is your data frame and this is rolling method. Okay. Passing the here your value of on which window size you want to see the rolling mean, rolling average over the time. Either you are looking for weekly like 5 days, 7 days, you are looking for a month, you are looking for 2 years, like that. Okay. It is by following your mean and standard deviation method. Okay. So how it is useful? First, I will make you understand how it works. Okay. So we will take here the example, this one. This is the just sales like corresponding to these leads number, right? This is a number of days. On the first day, how many sales are done, second day, and so on. And when I apply the rolling mean on that, right? So how it will do? Let's suppose I want to apply the rolling mean or moving average for 5 days. So I will pass the 5 days inside that. It will take the value from these first 4 days and start showing me the average from the 5th day. Okay. So this will become NaN. Okay. When the method is applied, and then it is my first value of roll mean average. If you calculated it manually, how you can check, cross-check it like this way. So on the first day, how many sales were done? 61.417. On the second day, plus, and so on up to the 4th day, right? Sorry, 5th day, 73 per day. Then divided by 5. Okay. So this is the window size of 5 days. Okay, over the time. And then we will take the average. So it will show you the average here. And then going on. Okay, so it will doing the like mean from this. Okay, then it will start from the next 5 days from here and then calculate this, so on and going down. Okay, this is how your rolling mean work. Okay, so now it is easy for you to look for the trends. If you are using rolling mean average, you can see clearly the trend in the last 5 days. For example, if you want to forecast the COVID cases, right, for the next 5 days, how would you do that? You have a long, big data, right? You know the trends, but it's not easy to predict those trends, right? Not easy to understand. So what we will do, we will apply the rolling mean average on the previous 5 days. Based on these, we can predict the next 5 days forecasting of the COVID cases. Okay. So these are the very good examples of these things, like for the big data, right? How you can apply these. Now we will take another example of the rolling mean average. Okay. This is with your visual. Now here, this is my data frame. This is your method rolling over the 5 days window size. We call it window size, this method. Sorry, this parameter dot mean. Okay. So now when I applied it again, it did the calculation in the same way. First 4 days is a NaN converted into. On 5th day, it is giving you the average of the previous 4, including previous 4 days. Okay. And then this is a blue line is your original data, raw data. Okay. And rolling mean is the orange line. Okay. Now look at this. The blue line is coming up with the very noisy data, and it is showing you the very like that trends up and down, right? This you can see a very big spike here, here, and here. But when you apply the rolling mean of 5 days, it's easy to track, right? There is a no noise in the data, right? So it is showing from here and then going up here. Okay. So this is the advantage of the rolling mean. It will help you, right? It will reduce your noise from, it will reduce the noise from your data set. Okay. So you can clearly see the trends over the time, and then it will help you to forecasting the, like, your model. Okay. And now this is like using standard deviation rolling mean. In rolling mean, using mean method, it was taking the average of that thing, right? Now we will talk about the standard deviation. Okay. Standard deviation is helping you to see the standard deviation changes slowly over the time, right? In that, we were looking at the mean here. If you want to look for the standard deviation as well, how it is changing over the time, then you can use this method. It will help you to know how much values are like still over there, right? Now this is your standard deviation with the moving average. So the moving average is a blue line, the darker one, and standard deviation of plus moving average of this one is the green one, the shadow one, right? So it is telling you the data is still here, but how it is changing over the time as well. So you can see the variance in the data as well, and you can see the moving average trends as well clearly. So these both methods are very, very useful in big data in forecasting models. Either we take an example of COVID, we take an example of any other big data, right? So it will help you a lot in those kind of things. Okay. Now, what questions do you have till so far?
In Nirja, is there an advantage to doing this versus like resampling? So say you have like this daily data and you resample it to weekly. Is there an advantage to using like a rolling mean, for instance, versus doing a weekly resample?
Yes, you can, because resampling, we are just looking at like if you have, for example, you have a three cryptocurrency, right? Different, like the coins. You want to see the how the different currency, each currency over the year showing me the like data, right? You want to collect them, right, over the years, but based on the different thing. So resampling is different thing, right? But when you are interested to see the trend using the same data, you want to forecast the model using the same data set, then it's a good habit, good practice to do the rolling mean average, because resampling is only helping you to see the data over the time, right? It is not helping you at all to see the like trend in a slow way where you can track the like the mean, right, how it is changing over the time. But this is helping you to track the how the mean and standard deviation is changing over the time. Okay. So this is for that thing useful, especially for forecasting models. This is highly recommended.
Sweet. Thank you.
So would you do resampling first to prepare your data for this, or is this in place of resampling?
You can do it like this is your choice how you are doing the like you want to see resampling. We are doing the resampling to just like doing the analysis to look over to group by the data, right? It depends how your data set is given, right? Now, for example, if we take an example of again the COVID one, right? In the COVID, if you have a data set, first you have a world, then you have a countries, then you have a state, then you have a cities, right? Now, maybe your choice is only to look at the cases per city only. You are not interested in any country or other state or other things, right? So what action you will take first? First, you will do the resampling. You will group by it, right? Over the time of this specific country, then go with the state, then city. You got the result, right? Now picture is clear. How many cases per city in this state, in this country, right? Now what I will do, I will take out the city which I'm interested. My stakeholder is not interested at all in the country name. Maybe he is interested only in specific state, right? Then now the next step is I want to see the trend in this city specific over the time. Now I have a data set of 5 years. It's tough for me to look for the trends, right? Now it's a time to apply the moving average. Okay. So this is the way you need to think like this way. Okay. It totally depends upon your requirement. It is not fixed like you need to apply for resampling or these things. Any other questions? Good questions. Great. Okay, now we will talk about some feature engineering here. Okay. So this is very, very useful when you are interested to take out specific part of the date, right? It is useful sometime by when you are plotting the graph, right? Here, maybe, again, I will give the COVID example here. If you want to interested in which year, in which city, what were the COVID cases? You want to plot this only. Then you can use this attribute. This is your date and time instance, okay? This before this here, your data frame will come, instance. Then dot, then date and time instance, then dot year. If you are interested in month, you can use dot month. This will print only number of the month, not the name. If you want to print the name of the month, you will use this one. Okay. And then day, this is the number, this is day name, hour, and seconds. Okay. How it will look like, you will see in the code along as well. Okay. Now calculate the decades and centuries. This is very helpful. In time series, this is very, very helpful. Sometimes you really need it in many data sets. Okay. So in this, how would you do that? If you want to like create the decade column, like the difference, how would you do that? This is your year column, right? This is your year column, and you will do the modulo of the year. Okay. This means 1949% of 10. So it will give you the remainder, right? Not the quotient. We are talking about the remainder. So when the remainder will come, we will subtract it from the year. So you will get the decades. So this is how you calculate the decades in your time series. This is the method. Okay. You need to, we can say like divide by 10. You will take the we not say we don't say it divide sign, we will say it modulo sign, right? Modulo sign and then divided by 10, whatever remainder you will give get, you will subtract it from the current year and it will give you the value of remainder, decade. Okay, and that will become your decade column. This is very helpful method. Okay. Now we will talk about the another most important topic you are going to face oftenly in your time series again, seasonality. Okay. So if seasonality means it is showing you, as we have discussed in the first slide as well, it is going to show you the pattern that will increase and decrease over the time, right? And if you look at this crime date and time, and this is the numbers, how much crime is increasing and decreasing over the time. In 2017, it's very high. Then going down between these months, again going here up. Then going down, here it is very high, like this. So it is showing you some seasons over the time. Season means it following some pattern. If in 1 year, between your June to July, something is going up, and in the next year, it is again going up in the same month. So this means it is showing you the seasonality over the time, right? If you look at here in the below example, this is your, again, US retail sales, right? Over the year. Here it is started in the low, but it is going up and only up. In this year, it is going down here, again going up in this. So this is seasonality. Okay. This is over the time. Sometime it is increasing, sometime it is decreasing. Okay. Season means over the time, sometime following the same pattern. Okay. So this is seasonality definition. but it is tough to look at that seasonality in one graph. Okay, so pandas is giving you the very good option that is called seasonal decomposition. So what it will do, it will cut your graphs into 3 parts. Okay, in that you can see the trend, you can see the season, you can see the residuals of the data. Okay, now look at this. How would you apply it? It's an inbuilt method, seasonal underscore decompose, right? So if this is your graph, seasonal graph, it is when you apply this method on this, first it will plot a graph of trend. Here we can see the trend is up, right? Your data points is very, very high between, we can say, from this middle June of the 2017 and going up to down, start going down from 2020, right? So you can clearly see the trend here. But if you look at this above graph, normal graph, you can't see the trend clear here, right? It is helping you to know the trend very clearly. And if you look at the season, see, same pattern following in each year, right? So you can clearly see the season of the seasonality of the data. Now here, it is just showing you the residuals, right? Variance and mean. So here, this is a mean, this is a variance, this is high variance, right? So this means it is close to your mean, every like your data points, right? So it's easy for you to track the things, to understand the pattern of the data set over the time. Very, very useful graphically if you want to dive deep into your data. Okay, so you can take a decision by looking at it. Now, what questions do you have about seasonality? Right? This is how you can answer the stakeholder questions. Whenever you have a time series data set, only most important 2 things. Apart from this, we have other things as well, but this is a very important 2 things. You need to keep your data in the form of true time series with daytime index with the specific frequency, right? Frequency means, as we have discussed in the first lesson, by default, it don't have any frequency. You always need to set it, right? By doing resampling, right? It is depend upon your requirement. You want to look for daily, monthly, yearly, weekly, right? So you can, this is very important before showing the data or any report to the stakeholder. You should know, right? What's its frequency. A tabular data frame with engineering features, date parts. What is that? Feature engineering means, which we have discussed a few seconds ago. If you want to show any graph to your stakeholder, are you going to show it day wise? Are you going to show it year wise? So you need to extract it, right? If you remember this one, this is, right? You need to plot something on your graph. Is it with the date name, day name, or I would recommend with name is very good when you are showing to the front end, like the stakeholder. Okay, they will easily understand. So this means you can tell them if it is showing on the x-axis the month name, he will automatically understand you are showing the graph on monthly basis, right? So this will set your frequency. So this is 2 things very, very important. Okay. Before jumping on to the code along, I have a one question for all of you. Which have a seasonal component out of these graphs?
A.
Okay.
B.
D or B? Anyone else? Okay, good. Very good. Very good, Shinayo. All are doing great. Okay, yes, right? So these all are good. Yes, right? Because this graph is stationary. There is no season, no cycling, no trend, nothing. right? Good, great job, thank you. Now we will jump onto the code along. Before moving ahead with the code along today's lesson, I would like to continue from the previous lesson where I left. So this is over lesson 1. So I left here working with the wide form time series data. Okay. So what is a wide form series data? When you have a date and time column, like the input in a column form, not the row wise. Okay. So it will become the wide form data set. So how you can see here, it contains only 3 rows, 3057 columns, right? Whenever you see this form, this is mandatory or required to convert it into log form. Okay. So how would you do that? We will use the melt function here. So we will take out the here, only select the ID columns using this method pandas, right? And then we will declare a variable long crypto pd.melt. Here we have this over crypto data set id wheres is equals to id wheres. This is the one, right? Your cryptocurrency symbol and currency. This is the IDs. And then see, it is converted into now long form. So this is your new column because I did not give any name. It's a showing variable. You can give it date and time. Okay. And this is the value. Okay. And then if you come here, now this is, we are just renaming. Here we go. Now we will, what is our next step? Now my wide form is converted into long form. Next step is we will convert the data time type, right? Date and time input type. So I'm using here pandas 2 underscore date and time method, right? It is converted now. Good to go. What is the next step? We will set the index, right? So we can track it easily. So here we go. Now, did anyone notice anything here? When I did the long underscore crypto dot set underscore index, my index is coming here. This is fine, right? So if we look at back here, how it look like and now how it look like, right? Did you notice the difference? When we did the set underscore index, this column name is not coming along with the other column names, right? It is going down, right? What is the reason? Now, if you look at these, after this, why it is showing like this way, I will tell you now. Here, we will check the frequency. There is a no frequency, so we will resample the data, right? In this, when you resample the data, this is your cryptocurrency data on daily basis. So I will resample it on daily basis, okay, as a frequency method. So now look at the result, how it is changed. Now this Bitcoin, Ethereum, or other your crypto type currency is showing the values, symbol, and everything based on each day with the your name of the cryptocurrency, right? Now data is separated, well separated, right? We can understand this is the currency, this is the value, this is the date, right? It is not mixed. Now in this, what is the problem? If you are looking for the values, you can, right? But it is coming in the form of your cryptocurrency, this one in the form of series right now. Okay. So when you will try to plot the graph here, it will look like this way. Okay. When you want to see the trend for each cryptocurrency, right? You look at this result. It is showing the one Bitcoin here. This is clear. But this is showing one line here, one line here. This is your 3 cryptocurrency types. And it is not making too much sense to me. If I look at the x-axis, right? It is not making sense to me. So what we will do now? So whenever you see this thing, okay, this is called multi-index. This is not simple index. Okay, Multi means first this index will come, let's say 0, then this index will come, okay, with this one. So whenever you want to access this one, you need to go through from here, okay. So how you can remove that? You need to unstack it. So that's why you are passing the 0 here, okay. When you will use the cryptocurrency, your data frame unstack 0 here, it will come into the normal form, okay. Now your cryptocurrency is here, right? Bitcoin, your Dogecoin, Ethereum, these all are there, okay. Now when you unstack, it will create some your these values because this is according to the index, right? Now if you plot the graph here, look at the result now, the big difference now, right? It is showing you the clear picture over the years, the different type of the currencies, cryptocurrencies, how it look like, what is the trend, right? What is the price value of each one. So this is a very important whenever you see it multi-index, how you need to handle that, right? How you need to do the resampling, then you can plot the graphs and see the things clear, okay? Now resampling demonstration, this is just I am making the copy from only 2021 to 2022 data set. We are not taking the whole data set because it is not showing any value from here, right? So we can keep up this one. When we plot, it is showing over the month from January 2021 to so on. Okay. Now after this is your resampling. So resampling you can do weekly, monthly, daily, quarterly, annually. This is we are doing it on the using weekly only. Okay. By aggregation method from the last. Okay. But maybe you are interested to look for the collective way. So we will make a one list of the frequency here, daily, weekly, monthly, quarterly, annually. Okay. And you can run the loop over your graph here. Okay. Now when you run the loop over the graph here, it will start showing you. So here this is orange is original, blue is your like the this one daily data. Okay, based on frequency. Here it is overriding because it's like showing the daily data with your original one. So we can't see the here orange line. But when you look for the weekly, see the difference. So it is showing you the weekly here data, right? Now when you go for the monthly, now it's coming more broad, right? From here to this one, then this one, then this one, right? Originally is daily basis, but this is going on monthly, right? And then this is quarterly. So it is quarterly because it is taking from January to April data. So it started from here going down, then these. It is not making sense, although, right? Because it is showing me, I don't know the trend in this clearly. So this is just showing you to how it will look like if you want to use more than one frequency. Okay. And this is yearly. Okay. So this is all about how you can like change your wide form to long form and how you can use the different your frequencies over the like using the time series data and see the trends over the time. So here we are just doing nothing. We are again saving over final data sets into the folder. I have made this local folder and then just make a directory, save inside this. Okay. So this is import OS folder, create a folder inside your local environment. And this is again the folder and then os.make directories. We will pass the folder exist underscore okay true. Okay. After that, we will give the here name of the file, connect it with it, and then save it. If you want to read it, you will unload it again. Okay. So this is all about from our previous lesson. What questions do you have till so far? Right. So we will jump to our today's lesson. Now here we go. Okay. So now today we are going to take the UFU data, UFU sightings data set. Okay. In this, first of all, this is we are importing libraries. This is normal. And here we are loading the data set. I will make it broader. So this is our data set. Now in this, we have a datetime column, other column city state. How sightings, UFO sightings are based on date in this city, in this, like the state and country, okay, with the location as well. So now what is our first step? In the date time series data analysis, we first convert our date and time into convert the date and time like data type, right? Here, if you look at this, I did what I did. I say pd dot to underscore datetime UFO datetime. But what it is doing, it throw me this error, parser error. It is saying hours must be in this and this. Why this is error is coming? I will show you. Okay. If you remember in the first lesson we discussed, you have a 3 type of parameter when you want to see the error, right? First is you will ignore. I will not recommend it at all. Otherwise, how you will solve the problem, right? So this is kind of the things we always use in the exception cases, right? But we can use a raise and course method, okay? So in this, like this is your choice, you can try, okay? I'm going to use a course method here, right? Now look at the first missing value. How many missing value we have in this, okay? After that, we will make a copy of the date and time column, create and keep it saved in another column. We can name it date time original. So I can take action on this. Okay, I will not touch the original data set. So I have created the column. It is created here. Okay, now we will convert to underscore datetime, UFU datetime error scores. Okay, so in this, I have applied the parameter codes. Why I am applying? If it will throw, it will say not a time if this value at specific data point is not in the form of date and time. Okay, I want to see why it is throwing this error. So when I pass this parameter, okay, here it is showing this result. Now, if you look at this again, missing value, look at the result. Daytime course column is showing 694 missing value. From where it come? We have created it. Okay, to see it. Now we will take this column only from here. So when we take this column from here, look at this missing value. Okay. Now, how many bad rows in this daytime course is now? Here we go. See here, all values are coming here and not a time, not a time, not a time, right? Because we have used a parameter errors is equals to course. So it is showing this much values. Now, look at the error. This is the exception we are creating. It's tell me parser error hours must be in this form. Okay. So what does it mean? This means my time is coming with this thing, 24-hour clock. Okay. So my Panda is not able to interpret, is this the previous day or is this the next day? Okay. So it is expecting the time, the hours must be in the form of either 23 or 11:59. Okay. Or it must be like say clearly like 12. Okay. The 12 one. So it is getting confused with this format. So that's why it is again and again showing this error. Okay. So how would you handle it? So now look at this. We will use here string replace method. So whenever it found in this column, I will create a new column, date time fixed. Okay. So it is my original column. And then we will convert over 24 hour into 23 dot colon 59. So now my pandas, when we will apply 2 underscore date and time on the data set, pandas when will interfere in this, it will detect it is the previous day, right? It is not the next day. So it is detectable. So this is how first we will replace. Now we will convert this date and time fixed column into the date and time, because these were the only values which were left, right? All rest were already converted. These were the value which were left, right? And now when it is done, see, in the daytime time fixed column, there is a no missing value at all, not, no, I will not say missing value, not a time value. Okay, it's a clear now. But in the previous, we had a 694. This is fixed now. Okay, here we will now set the index of over with the date and time, because everything is set now, not a time value is set now, converted into proper date time format. Now we don't require these columns. Okay, because we have set everything. This is we created just to fix or do the analysis. We don't need it anymore. Okay, so we can drop that. Okay, now what questions do you have till so far? Any confusion till so far? How we have used the course analysis equals to course, just to say rest everything is working when you applied the pd dot 2 underscore date time on the whole data set using the parameter analysis equals to course, it convert the all like your rest of the timestamp into the date time format timestamp pandas, except with the the leftover the values which was showing the 24-hour format. Okay, it did not throw any error, but it just show you not a time, so you can handle those. Okay, this is the advantage of the course. So now we are good to go, all set. Okay, now when you plot this graph, look at this. It is like a plot nothing, right? We can't, it is not making me sense. What is this, right? Lot of values. Okay, so now the question is, what do we really want to know about UFO? You need to think, right? You want to look for the duration of the sightings. You want to look interested maybe location of the sightings, number of sightings, right? So we will see the data set here now. These are the questions like we will do. I will start with this. We want to quantify the number of the events that occurred within each interval. Okay, how many times that event or occurred over the time or maybe at each interval. So what I will do first, I will make the copy of my this data set which I have prepared in the demo your time series. I will create a new column here, count is equals to 1. Okay, because what I want to know, to quantify the number of the events that occurred over the time to the specific date. Okay, how many times? So we will create a sample column with the one, this one. Okay, and then we will resample it on daily basis. Okay, when you resample it on daily basis, because I want to know the total number of the events happening on the same day, so I will resample it by daily using the method aggregation sum. Okay, when you use a sum, it will show you in 1906 on 11th of November, this is the place. What is the count of the number of the events of the sightings or number of this? 1. And it will start showing you the total count, total sum of the events happening on this specific date at this place. Okay. So this is how it will work. You can do the same thing using the size method as well. Okay, this is your choice. Both will work. You can do it with size or either with the sum. Okay, both will work with the resampling of daily basis. Now what we will do, Here we will not go. Just look at the graph now. When you did not resample the data, it was showing little weird. We were not able to interpret anything. But now you have resample it on daily basis. Now see the result. It is much clearer than the previous one, right? Because otherwise, what it was doing, it was showing you 1906, 11 November, this much number of sightings in the state, country, and city. In 1906, 11 November again, in the different country in this. Now we are only interested in the date. We are not bothering about the country, state, or that thing, right? We are just looking the total number on this date. That's why it look like this way now. Okay. Now, what questions do you have till so far? Okay. Now here we can see from 19, or maybe we can say 1920 from here. It does not seems to be a very good data, so we can skip this year. We can start from 1950. At least it is showing some data, something. So you can plot the graph from here. Okay. So this is the result. After applying indexing, conversion, sampling. Okay. Now, the few more questions, these questions we will do together, and these questions you are going to answer in the breakout room. Okay. So what month, year had the most sightings? Okay. So now we will reset our index again in the original one. We will create a new here data frame, copy of that, and then let's start. So this is how you can apply the feature engineering, which we have discussed in the slide. Now I'm interested to look for the number of sightings over the month, right? So I'm interested in showing the month on my graph. So what I will do, I will take out the year, month name, day name, date and time over, and just create the columns here. Look at these. Here we go. This is the day of the week. It created this column. This is our day of the month, year. It's too easy for you to show on the graph now. Okay. You have extracted these parts from the date. Okay. Now you can use it straightforward. Now we will come down. Here we are just adding the weekend feature that will be true if the day was Saturday and Sunday. Maybe nothing, no event has happened on that day. Okay. So we will create a new column, weekend, at the end. If it's a Saturday and Sunday, then it will say true. If it's not a Saturday and Sunday, then it will say false. Okay. And now here we go. How you will calculate the decade, right? It is your year column subtract year column modulo of the 10. Okay. We will create a new column decade here. So this is the decade here. Okay. We are creating the decade. So we can see in which, like the year, on which date, how many we have the number of sightings over the month. Now start answering the stakeholder question. So making the EDA with the date and time, we will set the index. Here we go. Now what month, year had the most number of sightings? Okay. So I am resampling it with the month. Okay. And size. You can also use the sum. This is your choice. Okay. Now when you resample it, it will plot this result. Okay. Now you have plotted this result. You have so many years. Maybe you are interested only in the maximum number of these sightings on this specific date. Okay. How would you do that? You will use the IDXmax function here. Okay. In which month? Highest number of the sightings. So when you plot it, it will show this. We will check the index location of this value using the log function. It's a 902. Okay. And now we will plot the graph. So when you plot the graph in this, we will highlight with the vertical line in which month the highest number of the events have happened. How would you do that? You will say axis dot axis vertical line. This is your value which you have calculated. This contains the highest number of the count of these events happened on this date. And then color is black, label is equals to this. Now look at this result here. It is clearly show you here the number of events in this month, in this year is the highest number of that. Okay. So this is how you can show on the graph. Okay. What questions do you have? All? Anyone? Now, which month of the year has the highest number of reported sightings? Okay. So now we will talk about the number of sightings after the number of events. So in this, you can do the value count. We can clearly see, you can sort it. It will show you the highest number on the top, right? So now, if you want, you can plot the graph as well. You just remove this comment and just plot it. So here, is there a seasonal pattern to UFO sightings? If you want to look the seasonal pattern. If so, how long is the season? Okay. So for that, you will import the stats model TSA time series dot API as a TSA. Okay. This is you need to import to check the seasonality. Now we will check the only above the year 2000. Okay. So I set this season. Now look at this. Can we see the seasonality in this over the time, right? Because it is increasing, sometimes decreasing, but after 2009, it is very high, right? So now, if you want to see it clearly, if you are not understanding in a one graph, here we are going to use the seasonal underscore decomposition method, right? And we will pass over this seasonal plot, which we have prepared here. Now it will decompose into three forms. This is your original one. Now see the trend, right? We were able to see the trend, right? It is started from the lower and then it goes up from after the 2010, right? We can see the trend. And this is the seasonality with the mean 0 here, right? Here. Time. And this is the residue. This is the mean. This is the variance of the data. Okay. So this means this is not going too much outside. This is showing the trend over the mean, season here. And this is the residuals. And this is the trend. So this is very, very helpful when you have a seasonal non-stationary data and you are not clear with the things like how it look like. Then at that time, you can use this function. Okay, very useful. Now this is for if you want to decompose the seasonal, separate the seasonal component and the plot. Then you can use this method. Okay. And then it will plot like this way. This is for that thing. So it is showing you here is the mean, here how it is working, above going the trend and the seasons, it seems to be same, right? How it is like your variance and your mean is changing over the time, right? It is showing you that thing. Now, if you want to find the peak dates in this, how would you do that? From this package, you will import this package, import find underscore peaks. We will create a two variables here, props and the peaks. Find underscore peaks is the inbuilt your method. We will pass seasonal maximum, right? It will only show you the peaks now. Whenever over the time there were the number of sightings were high or at the peak. Okay. So we will show the peak. These are the dates. Okay. Now, which US holiday has the largest number of the sightings? Okay. In this, you will import the holidays library, date and time. From the package holiday, you will import the country holidays. It is inbuilt. Okay. Whenever you Then you can choose a country name USA. It will only, now just let's test the date 1st of January of 2015. Okay. It is a New Year day. This is a holiday, right? Now map the APIs get method onto this. What you will do, map method will automatically track based on the index the number of holidays in your whole year. This is a inbuilt your method, very useful method of pandas. Okay. So map will do out, you can see it take out all holidays in a year. Name of the holidays. Okay. Now answer to which holiday has the most sightings. It's very simple. We will take the column of holiday value count. It is showing most of the number of the sightings is taken on Independence Day. Okay. This is how you can take out. This is so easy in in Python. You just need to import the holidays library, set the column, and just take out the value. Now we can see if you want interested which movie was come out on that day. Like if you take the release date, we are just taking this and then you can plot it. This is the same way we are plotting as we are using the vertical line as we have previously plotted the number of events in which month it was with the high value. Here we are plotting the releasing date. It is in the exactly showing, we can say 1995 here or 1997. Yes. Okay. So with this, it is showing the release date here on your graph. Okay. So these are the all about your seasonality, feature engineering, how you can conversion, apply the different methods to look for the your different trends, seasonalities, cycles in this. Okay. Now it's a time to break out room. Okay, all of you will get a chance to discuss with each other and answer these questions. Which year had the highest percentage increase in sightings compared to previous year? What day of the week has the highest reported sightings? Okay, at what time of the day or do the most sightings? This is you can use your our column which we have created. Which US state has the most sightings? Which country had the largest proportion? Have the types. Okay. You can use only the for the last question, you can use the top 4 most common shapes only. Okay. Any questions till so far before I open a breakout room? Any confusion? Okay, take your time. Now I will open the breakout room. We will set time. All right. I will share the link in the chat as well. You can copy the code from here. You can make a copy of this one. Okay, so everyone is back. So let me share my screen.
Victor, you are muted. Okay.
Okay, so did everyone from other room tried the question? Good. I will share the solution later on. You just keep on trying, okay? So this was a summary. We did today time series calculation and comparison. Calculate seasonality of time series, how to answer the stakeholder question. And in the next class, we are going to do the tableau. So this is highly recommended to install the public desktop version on your system. Okay. So we will start the tableau next week. If anybody have any question, any confusion, they can stay and ask. So I'm going to stop sharing.